Hey, Miss W here, going to talk about rational expressions and how to simplify them. But first, let's understand what a rational expression is. So I have an example here. Notice that you have an algebraic expression, meaning that there's variables in both the numerator and the denominator. Now, what you need to remember or know is that x cannot be 0. Otherwise, this is an undefined expression. So beginning there, we're going to just know that there are limits that x cannot equal 0. So when you're simplifying or solving, we are going to refer to that after a while. Maybe not in this lesson, but some to come. All right, moving on from the rational expression, let's talk about simplifying one. So here we have an example. Now, if you remember your exponent rules, you could just go ahead and simplify your 4 and your 6 to 2/3. Your x would stay there, and you would have y1 minus 2. So you would have y equals -1, which means you would have 1y on the bottom. Now, I'm going to show you a different way of simplifying this because this is going to come in handy when we simplify harder ones. So let me rewrite this equation as 2 times 2, which is 4. I'm going to break that down to the prime factorization. And I have 1x and 1y. In the denominator, I could say 6 is 2 times 3, my prime factorization. Y squared is y times y. Now, showing you this way, you can see what's easy to cancel out. So I can cancel out my 2's here, and I can cancel out one of the y's on top and bottom. So I'm left with 2x over 3y. So keep in mind, we're going to be looking for common factors that we can cancel out. So moving along to our rational expressions, I have 2 expressions in the numerator and in the denominator. I'm trying to simplify my rational expression. So if you remember, I told you would have to have the skill of factoring quadratics. So to begin with, I'm just going to copy or look at my numerator. Looking at my numerator, what do I see about the 2 and the 6? Is there a common factor, GCF? And you're like, oh yeah, we had to do that for Miss Witherell. I remember. So from 2 and 6, we can pull out a 2. 2 is the common factor. So 2 divided by 2 is 1, and then I bring over the p in parentheses, plus 6 divided by my 2 is 3, and I have nothing left to factor. So now look at my quadratic on the bottom. Remember when you have your x's, or this is the case of p, if this symbol is negative, one is always going to be a plus and a minus. So now I'm looking for factors of 6 that add up to 1, because there's a 1 in front of that p, a positive 1. Well, 6 and 1 won't work if I have opposite signs. That would be 5. Factors of 6, well, 2 and 3. 2 times 3 are factors of 6. I need them to add up to a -1, or a positive 1, excuse me. So that means that the 3, the larger number, has to be positive, and your smaller number is negative. So I'm just going to copy that over on the denominator here. P plus 3 times P minus 2. Okay, so why do we have to do that? Because we are simplifying expressions. So in doing that, you can see that there's a p plus 3 on the top and a p plus 3 on the bottom. They cancel each other out. So in simplifying this expression, you're left with a 2 in the numerator, and you can have the parentheses or not the parentheses. I just use the parentheses, and a p minus 2 in the denominator. That's all you can do. That's the simplest form. Let's try another one. You're saying, yay, let's. And hopefully you are writing these in a notebook so you can remember them and do the steps with me so you can remember them when you have to do them on your own. So one more for this lesson. All right, one more condition I want to tell you before we move on is notice your denominator is p minus 2. Now remember we said that your denominator cannot equal 0. So what number would p have to be to equal 0 if I'm taking away 2? So if p minus 2, if that would equal 0, to solve for p is 2. So if I plug 2 back in here, I have 2 minus 2, which is 0. So that cannot be. So when you're solving this, you're going to have a condition that p cannot equal 2. And you'll see that in answer choices where what numbers are exempt. So moving on to this one, I want you to treat this like two different problems. Go ahead and factor your numerator and factor to your denominator and see how you do. Pause this video and see if you can factor them first. All right, in factoring these, on the top, you start with your two parentheses. You should know this. You know you're going to have an x and an x. This last symbol is a minus, so I'm going to have one plus and one minus. So factors of 27, opposite signs that add to a positive 6. You should have gotten 3 times 9. Which one has to be positive if I need a positive 6? The larger number. So I factored that. So hopefully you got that too. So on the bottom, you know you start your parentheses and you know you have an x and an x. You look at this last sign, you see it's a minus, so you know you're going to have a plus and a minus 100% of the time. So factors of 63, opposite signs that add to a positive 2. Let's try 9 and 7. Which one has to be positive if I need a positive 2? Adding them, 9 and a negative 7 is a positive 2. So now that we've factored those, notice you have something in common on the top and the bottom. So we are going to cancel out those x plus 9s. And we have x minus 3, x minus 7. And what is the condition that we have to remember? What number cannot x equal if I have a minus 7? Remember, it cannot equal 0. To find that number, you put x minus 7 equals 0. So x equals 7. So if x is 7, it will be 0. So we cannot have that. So we have to state the condition. This is factored and true as long as x does not equal 7. Pretty cool, right? Having fun, I know you are.